Hello, and welcome again to Code Red Games' journey through the book 3D Game Engine Programming. So the chapter of the book I've worked through is all about shaders and using the renderer from last time to build a demo program that can do some pretty cool things in a reasonably performant fashion. Unfortunately, getting through this chapter took quite a bit longer than I expected. I was hoping to get through it in a week, and instead I'm here in 2.5. The main reason this happened was that I turned out to have quite a few bugs in the renderer that weren't apparent until I actually tried to use it to, render something. Mostly these were the result of the code samples I followed not playing that nice with Unicode. Readers of my blog will remember that I encountered quite a few teachable moments toward the beginning of this project when I realized that the default for character set support had changed from ANSI to Unicode in the years since the book was written. Well, it turns out that those moments didn't actually go away, they just got harder to recognize. So hunting all of these down took quite a while, and honestly, it was pretty demoralizing. However, once I got through all these issues, I got the opportunity to learn all about shaders. Until now, I've never worked with them before and only had the vaguest sense of what they do from adjusting my graphics settings in a game. The book's coverage was great for learning the basic purposes of vertex and pixel shaders, learning about how the 3D graphics hardware pipeline works, and understanding some of the basic use cases of shaders like point lighting and bump mapping. Another appreciated aspect of the book I'd like to call out is that much of the shader coding, as well as the calculations necessary to feed data to those shaders, was intentionally done at a low level and with as few uses of direct 3D tools as possible, so that I could better understand how these processes work under the hood. Unfortunately, the corollary to this is that the book's examples are not at all helpful in their details. When using shaders for real-world applications, you of course don't want to reinvent the wheel. You'd want to actually be using all those handy API calls and high-level shader language features that the book completely skips. Moreover, the book uses shader version 1.1, which is positively ancient. For reference, I believe the last version of DirectX 9 uses shader version 3. And on top of this, the demo application's calculations tend toward using variable names that are quite undescriptive, making it hard to translate text explanations into what's actually going on in the code. And so a lot of the time, I got the feeling that I could understand the general concepts, but I would have a really hard time debugging this if I was actually writing production code. A final note that I'd like to call out is that despite the flaws in this chapter, it was good to get an opportunity to see how the renderer that I've been slowly putting together along with the book works in practice. And I have to say, given the complexity of the information that needs to be generated outside the renderer's API calls, my respect for the work done by developers on engines like Unity 3D has skyrocketed. Even beyond the engine itself, now I see how much work it takes to make the user-facing entry points to a game engine program accessible and relatively simple to pick up. So major props to all of you developers out there who are working on these engines and making them better for game developers and game enthusiasts. Well, that about sums up my experience of Zerp's and Duval's instantiation of shaders and their applications. Next up, I'm going to forge ahead to another chapter which is all about 3D animation. I may have another somewhat delayed update though, but it's for a good cause. Next week I'm going to the online video conference VidCon. If any of you are out there or going too, have fun and maybe we'll see each other there. And of course, don't forget to be awesome. See you next time.